Okay, so let's talk about ratios and equivalent ratios. I had already talked about ratios in the previous video, but this is just a little bit more practice and more focus on how to create equal ratios or how to check and see whether ratios are equivalent or not. So let's go ahead to things you should know. Here are just a few things that you should know. Of course, ratios can be written using a colon, which is the two dots, the word two, or in fraction form. You can scale up or you can scale down. Scaling up, of course, means multiply. Scaling down means divide or reducing down. And you can use a ratio table to create equivalent ratios. So if all else fails, you can solve a ratio problem. You can determine which ratios are equivalent or even build equivalent ratios by using a ratio table. So it's important that you know how to look at one and create one. Let's go ahead and move on. Let's quickly review about ratios using this practice that I created. So remember that ratio has to go in a particular order. So whatever order is written in, it has to be wrote in. So in this case, we want to know what's the ratio of hearts to stars. So let's quickly look and see how many hearts and how many stars. Okay, so hearts to stars. 1, 2, 3, 4, 5, 6. 6 hearts. 1, 2, 3, 4, 5 stars. And again, it can be written in any form. I'm just writing all of them. You don't necessarily have to. So let's go ahead. Let's look at our next one. Total shapes. So that means I'm going to include all the shapes and figure out how many. Okay, so let's figure out our total. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. We have a total of 15 shapes. And we just want to specifically talk about hearts, which we should already know from our previous problem was 6. In this case, we can simplify and reduce it. So let's do so. So what's a number that goes into both 15 and 6? 3. So I can go 15 divided by 3, I get 5. And then 6 divided by 3, I get 2. So in this case, it's telling me for every 5 shapes, at least 2 of those are going to be hearts. And I can go ahead and write it in the last form, which is 5 to 2. And we'll move on. Let's go ahead, let's look at the next problem. The ratio of flowers to hearts. Flowers, 1, 2, 3, 4, 4 flowers. To hearts, again from our previous, we know it's 6. I can also reduce on this. What's the number that goes into 4 and 6? 2. So I can easily divide each one by 2. 4 divided by 2, I get 2. 6 divided by 2, I get 3. And again, it's saying for every 2 flowers, there are going to be 3 hearts. And let's look at our last one as a quick review. Stars to total. We know that we had a total of 5 stars, and we know that my total is 15. Again, we can reduce this. What's the number? And think about it. What's the number that goes into both 5 and 15? 5. So 5 divided by 5 gives me 1. 15 divided by 5, I get 3. So again, 1 star for every 3 total shapes. Let's move on. Now let's look at some practice problems dealing with ratios and building equivalent ratios. Let's look at this first example. It says the ratio of cars to trucks is 3 to 5. Complete the ratio table. So basically what we're doing is just skip counting. So we know that the ratio of cars is 3 to trucks 5. And we could just continue by skip counting. So in this case, cars 3, 6, 9, 12, 15. Let's skip count on my trucks next, and then we'll write down each equivalent ratio. So 5, 10, 15, 20, 25. Now, let's write down our equivalent ratios. So in this case, my equivalent ratios are 3 over 5, 6 over 10, 9 over 15, 12 over 20, and 15 over 25. And we know they're all equivalent because we can reduce them down and they should all equal up to 3 over 5. Let's just try one for practice just to make sure. 15 over 25, I can reduce that by 5. And I get 3 over 5. Let's try another one. If I have 3 over 5, so again, 3 over 5 is my original ratio. Now let's try it with 12 over 20 and see whether they're equal. Remember, whatever we do to the top, we do to the bottom, or whatever we do to the bottom, we do to the top. So in this case, I can go 3 times 4, and that's going to give me 12. Let's see if we can use this same scale factor for 5. So 5 times 4, does that give me 20? Yes, it does. So in this case, they would be equivalent or equal. So let's go ahead, let's try some more practice. Based on the ratio below, determine whether these are equivalent to 3/5. So we just finished looking at some problems that had to do with the equivalence of 3/5. So we can also use that same ratio table and see whether they matched up. So let's look at this first one. So first one is 12 over 20, which was on our ratio table. So of course, if we reduce down 12 over 20, so if we reduce down 12 over 20 by, in this case, 4, 12 divided by 4, we get 3. 20 divided by 4, we get 5. So in this case, they are equivalent. So this one would be equivalent. Yes. So remember, not only can we multiply up or scale up, we can also scale down. So either one that makes it better for you. Since we scaled down on this one, let's see if we can scale up. So in this case, I would just simply write my ratio that I'm trying to see whether it's equivalent to and 25. So remember, whatever I do to the bottom, I also have to do to the top. Whatever I do to the top, I also have to do to the bottom. So in this case, if I go 3 times 5, that gives me 15. 5 times 5, does that give me 25? Yes. So these would be equivalent. Let's practice the reduced way again, and let's see if we get the same thing. So 30 over 5 over 50, I know I can reduce that by 10. 30 divided by 10, I get 3. 50 divided by 10, I get 5. This one is also equivalent. Let's move on. Based off our ratio table, we can already see that if it is 9 cars, it has to be 15 trucks. So we already know that this cannot be equivalent to 3/5. And then our last one, again, we can either reduce it or we can set up and multiply up. So 33 over 5, 24 over 40. I know that 3 times 8 gives me 24. 5 times 8, does that give me 40? Yes. So in that case, 24 to 40 is equivalent. Let's move on. Let's complete these ratio tables. And again, we need to realize that this is going to be our main ratio. So we're trying to make sure that all the ratios below it are equivalent to 2/9. So again, whatever I do to one side, I have to do to the other side. Similar to what we was just doing. So in this case, I know that 2 times 2 gives me 4. And so I would do the same thing on the other side. So I know that 9 times 2 gives me 18. Let's try the other boxes now. I know that 9 times 3 gives me 27. So 2 times 3 gives me 6. Let's keep going. I know that 9 times 4 gives me 36. So 2 times 4 gives me 8. I know that 2 times 5 gives me 10. So 9 times 5 gives me 45. And therefore my table is complete. Let's try the next one, doing the same exact method. So in this case, our equivalent ratios, or our equivalent ratio we're trying to create, is 4, 5. And we're going to do the exact same method. So in this case, we know again that 5 times 2 gives me 10. So 4 times 2 gives me 8. We know that 4 times 3 gives me 12. So 5 times 3 would give me 15. We know that 4 times 4 gives me 16. So 5 times 4 gives me 20. And then our last one, we know that 5 times 5 gives me 25. So 4 times 5 gives me 20. And again, these are all equivalent ratios. If I just simply reduce them down, they should always equal up to 4/5. Okay, let's move on to some more practice. Let's create 3 equivalent ratios to 4/6. So I have been throwing around this word scale up and scale down. We can simply scale up by multiplying or scale down by dividing. In this case, is there a number that goes into both 4 and 6? Yes, it is. 2. And we can divide that by 2 and scale down to get a new ratio, or to get a new number. So let's do so. So therefore, 2/3 or 2/3 is equivalent to 4/6. So that's one of my equivalent ratios. For my other ones, I could either create a ratio table, which we've already been practicing with, or remember, you could just pick any multiplier. Remember, whatever I do to the bottom, I have to do to the top. Whatever I do to the top, I also have to do to the bottom. So in this case, we can randomly pick any number that we want. I'm going to choose 5. So I can go 4/6 times it by 5 times it by 5 and create a totally new ratio. So in this case, my new ratio would be 20/30. So not only is 2/3 equivalent, but also 20/30 is also equivalent. Let's do one more so we can create our 3 equivalent ratios. Again, it does not matter which number you choose. This time, let's choose 10. So I can go 4/6 times it by 10 times it by 10. In this case, I get 40/60. So all of these numbers are equivalent to 4/6. Let's continue. Now let's look and see if we can when given 2 ratios, can we determine whether they're equivalent? Again, we have been practicing this whole time, so I know you got it. We can either reduce down or we can multiply up to see whether they're the same amount or not. So in this case, I know that 7 times 4 gives me 28. Can I also go 9 times 4 and get 36? Yes. So in this case, these two are equivalent. Let's see if we can also practice the reduce down way and see if we get the same exact thing. So since we already know that my common number is 4, I can go 28, 36, and divide it by 4. In this case, 28 divided by 4, I get 7. 36 divided by 4, I get 9. So in this case, this is telling me this is exactly equivalent to my above number. Let's go ahead and let's get the second problem real quick. We can't really scale down or reduce 4 over 9. It's already reduced for us. So we can use the multiply way or the scale up way to see whether it is. Or we could just reduce this one. Let's try just reducing that one and see. What is a number that goes into both 24 and 42? I'm going to say 6. It might be a bigger number, but let's say 6. 24 divided by 6, I get 4. 42 divided by 6, I get 7. So in this case, I don't get 9. So these are not equivalent. And again, we could check my answer by just doing the same thing. I know that 4 times 6 gives me 24. But 9 times 6 gives me 54, which in this case is not 42. So this would not be equivalent. Let's go over one last thing before I let you practice on your own independently. Our last thing we would have to know how to do is solve these equivalent ratios. The good thing is they're similar to proportions, which we have been practicing on. So you're looking for a relationship, or you can solve it just like you would normally would a proportion. So in this case, I see relationships. So it makes it a little bit easier when we use those. So remember, relationships can be vertical or horizontal. So in this case, let's go ahead and look at our first one. We have 2 over 7 is equal to x over 14. Remember, x is my unknown. Anytime we see a letter, that means it's an unknown number, and we're trying to figure out what that number is. So in this case, I could go 7 times 2 gives me 14. And we already know the rule. Whatever I do to the bottom, I also have to do to the top. So I can go 2 times 2, and that gives me 4. So in this case, 2 over 7 is equal to 4 over 7, or equivalent to 4 over 7. Let's go ahead and let's look at my next one as well. So in this case, again, we're looking for P as my response. We know that 11 times 3 gives me 33. Whatever I do to the top, I also have to do to the bottom. So I know that 10 times 3 gives me 30. So this is telling me that 11 over 10 is also equivalent or equal to 33 over 30. Okay, now that's pretty much all that I have. I hope I help you with this. Now, as usual, I will leave you with some practice questions to try on your own. Please let me know whether you understand it or whether you need extra help. Pause this video to practice independently.